Hi, in this video I am going to discuss the law of radioactive decay. The law of radioactive decay states that the rate of radioactive disintegration, that is the number of atoms that disintegrates at any instant t, is directly proportional to the number nt of the active nuclides present in the sample under study at that instant. Let me explain this. Suppose we consider a nuclear material. Suppose this is a nuclear material. The number of particles present initially is n naught, and as per the law of nature, the particle will disintegrate. So at any instant t, let the number of particles become nt. So according to the law of radioactive decay, it states that the rate of disintegration, that is this one, the rate of disintegration is directly proportional to the number of active nuclides, or you may also consider atoms, present at that instant t, at that time t. So this is the law of radioactive decay. To remove this proportionality sign, we bring a proportionality constant which is known as decay constant. You may define this as dnt upon dt divided by mt, which is decay probability per nucleus per second. Decay probability per nucleus per second. Doing some sort of mathematics, bringing this side and bringing this dt to this side, doing some integrations, we are getting this one. Obviously at t equals to 0, as it mentioned at the beginning, the number of particles in that sample was n naught. So obviously if you know integration, you can easily do this, and the constant is c equals to ln n naught. Putting the value of c in this equation, we get this. So ln t equals to minus lambda t plus ln n naught. Bringing this to this side, we get, from the definition of logarithm, log a minus log b equals to ln ab. Obviously know that, and the base goes over here, and you will get this equation. Let me name this as equation number 1. This has immense importance in nuclear physics. So this is all about the law of radioactive decay. We can plot a graph from nt and t. Okay, you can see this will be a negative exponential graph. Put 0 over here. If you put 0 over here, you will get the highest value, that is n naught. And after a long time, if you consider that as infinity, though it's not real, if you consider infinity, it comes to 0, and you know the nature of exponential curve, so it will be like this. After a long period, after infinity, as per the law, it should become 0. So this is all about the law of radioactive decay. You can go through this. Hope you have understand. You should proceed in the steps. You should go through the steps once more. Okay, so let's go to half-life. Half-life. Obviously, it is in its name what half-life actually signifies. The half-life of a radioactive nuclide is defined as the time in which the original amount of radioactive nuclide is reduced by the way of disintegration to half its value. Obviously, as I have mentioned in the last page while explaining you the law of radioactive decay, if the number of samples is n naught, after a certain time, obviously it will become n naught upon 2, and that time in which it becomes n naught by 2 is half-life. So let me open this. You can see this equation. Let's put it over here. It's telling nt equals to n naught e to the power minus t. Obviously, for half-life, this nt now becomes n naught by 2. That is, presently there are n naught by 2 particles are left to disintegrate. This is the number of particles present at that instant of time. This is not the particle that has disintegrated. Don't be confused in this concept. This is important. I repeat, this is the number of particles that will be disintegrated in the future, or you may say that is the number of particles which is present at that instant of time. So obviously, if n naught upon 2 particles had been disintegrated, obviously n naught by 2 particles are present in that sample. Hope it's clear to you. So we may write this as T subscript half. This is the half-life. In this sort of time, n naught particles have been disintegrated and it becomes n naught by 2. From the graph, if you want to understand, obviously there will be a time. Suppose I am choosing this, it will become n naught by 2 at t half. Let's do some sorts of calculation. Let's cut a knot. Obviously you will get t half. Putting log on both sides, we will get this one, which implies t half equals 12 and 2 divided by lambda, which is equal to 693 lambda. This expression is important. In case of examinations, you can get this type of problems. They will provide you the disintegration constant, and they will ask you to find the half-life. So this formula is important. Try to remember it. Let's go to mean life. The mean lifetime of all the atoms in the given sample is defined as the ratio of the total lifetime of all the atoms or nuclei to the total number of atoms or nuclei. Mathematically, or you may say physically, you can also remember this. Actually, mean life is the time taken by the particles in the sample to reach n naught by E, that is 1 upon E of its initial value of the particles. Let me elaborate this. It means we already know that e to the power n equals to n naught e to the power minus lambda t. Right. So the mean life is the time for the particles to become 1 upon e of the initial value. That is, this value will become n naught upon e, and we're telling this term as the mean life. That is, if we equalize both, that is, if we take the powers only, we are getting tau equals to 1 upon lambda. This is very important derivation. So we can find a relationship between half-life and mean life. Since this half-life equals to ln of 2 divided by lambda, so we can write this like this, and as you can see that tau equals to 1 upon lambda, just put the value. So we can say that half-life is equal to 0.693 into tau, that is mean life.